Student counts use non-negative whole numbers.
You cannot walk on water, and you cannot travel backward in time. Physical paths have hard limits. Mathematical functions operate under those exact same boundaries. Watch the marsh first. The math is built into the world, meaning the quantities can be seen in the environment before they are formally named. We call the complete set of allowed inputs for any given relationship its domain. Before writing down that domain, we have to identify the physical, visual, or logical constraints of the environment the function describes. If a field trip costs 14 times the student count, the equation is C of n equals 14n. Remember, n represents whole human students. When a function models counting items, the context forces the sensible domain to be restricted exclusively to non-negative whole numbers, 0, 1, 2. Consider a physical event tracking a ball's trajectory from launch until it hits the ground. Look at the waterline axis. What are the allowable times for this event?
The input is time after launch. Negative times can describe moments before a chosen time origin, but they are outside this launch-to-landing model. The model ends when the ball lands at 4 seconds. The time domain runs from 0 through 4 seconds.
When relying on a visual model, the domain is strictly bounded by those physical start and end points on the input axis. Here, the domain is 0 is less than or equal to t, which is less than or equal to 4 seconds. We also find restrictions hidden purely in the algebra. The function h of x equals the square root of x minus 3 governs this waterway. There is an absolute mathematical rule defining this limit. The entire expression inside a square root must yield a non-negative number. We set up the restriction by pulling out that internal expression, x minus 3, and setting it greater than or equal to 0. Adding 3 to both sides resolves the inequality, establishing our final boundary. X is greater than or equal to 3.
For a square root expression like this one, the radicand must be non-negative. Solve that inequality to find its domain.
Reading the context, observing the graph axes, and solving algebraic restrictions are just different waterways leading to the exact same concept of the domain. The environment itself strictly dictates the logical relationship. The mathematical notation simply exists to record it. Which mark in the environment proves the mathematical relationship, and how does the animal action make it true?
The square root requires x minus 3 to be non-negative, so x is at least 3.